Hello friends. In this video, I will talk about my version of automating the conditioning process of lithium iron phosphate batteries in EcoFlow charging stations. If the device is not used constantly, such conditioning should be carried out every few months to avoid battery degradation and extend its service life. The stations can be integrated into Home Assistant via EcoFlow Cloud Integration. You will find a link to the video tutorial about this in the description below the video. This is what made it possible to create such automation. More details ahead, but before we begin, as usual, I ask you to like this video and leave a comment below. This is needed for promotion by the YouTube algorithms. If you are not yet subscribed to my channel, now is the perfect time to do so. The battery conditioning algorithm, according to the manufacturer's recommendations, can be conditionally divided into 3 stages. The first stage, the EcoFlow battery must be charged to 100%. At the same time, it's better not to use the maximum charging power. Set it to half or even less than the maximum. This will help avoid overheating the battery. The second stage, full discharge to 0%, essentially until the device turns off. If your model has a regular lithium-ion battery installed, then discharge it to 40%. A lithium iron phosphate battery must be discharged completely. The third stage, charge again, and again not at the full power that the station is capable of delivering, but now only up to 60%, not 100%. After this, the EcoFlow can be completely turned off and stored until the next time it's needed or for the next conditioning cycle. By the way, limiting the charging power also makes sense during constant device use. Of course, if there is enough time for this. Maximum power is only needed in those cases when the power supply is available for a short time. For battery conditioning, the following connection scheme is used. EcoFlow is connected to the power grid through a smart plug, which will turn the power on and off at the right time. To the station's output, to monitor its discharge, I connected an optocoupler-based electricity sensor. More about it in my video, link in the description. In addition, you need to connect some kind of load that will discharge the battery. Again, do not use the station's maximum power here to avoid overheating the battery. I use my IT infrastructure for this purpose: router, smart home servers, switches. All of this has its own backup power and is not affected by power loss when the station discharges. Now let's move on to the logic that implements all these stages. As usual, I put everything into one file, a package, the link to which you will find in the video description. All sensors, helper objects, and automations are located in it. You can easily add it to your system with just a few name changes. As an example for this lesson, I use the EcoFlow River 2 Max with a capacity of 512 Wh. Here you can see how it looks in my interface. I've displayed all the main parameters provided by the integration. Since the station has been taken out of storage, the charge level is now 60%, and this same level is set as the maximum. I used to do this manually. On the right, you can see the 3-stage toggles that I have now added and which we will discuss. Below the list of objects, there is a card displaying the current state. The load connected to the station is 88 watts. All power is being drawn from the grid. At the beginning of the package is a block of template sensors, which is needed to determine the completion of each stage, as well as for additional control, which I tried to implement to avoid errors. As I explain the logic, I will return to each of them and talk about them in more detail. The additional objects consist of 3 logical switches, one for each of the 3 stages, and these are the ones displayed in the interface. And next, the largest block, the automations. In addition to those that handle each of the 3 battery conditioning stages, as I already mentioned, I created several additional monitoring automations. Now let's go over and test their operation in more detail. Before starting the conditioning process, of course, the station must be connected according to the scheme I described, through a smart plug. Then connect the electricity sensor and the load to it. After that, all you need to do is turn on the first of the virtual switches, which is responsible for stage 1. It acts as the trigger for this first automation. The whole process takes quite a long time, depending on the station's capacity and the load power, but it no longer requires your participation. After I activated the first switch, the automation sets the battery charge level to 100%, since we need a full charge. Then the maximum charging power is set. For this model, I set it to 300 watts. Accordingly, it will be different depending on your model. For monitoring, the automations send notifications when triggered, but to ensure that the notifications contain up-to-date information, a small delay is needed. 5 seconds is enough for me to update the sensor values from the cloud integration and the actual notification, stating that the first stage has been started with the date and time of the launch. Then the current battery charge level, the target charge level, and the charging power. This is how it looks. On the left, the station has been taken out of storage and connected to the socket and load. The battery charge level is 60%. It is not charging above that. The charging power was set to 400 watts. In the center, I manually activated the first stage switch. The charge target is set to 100% and the charging power switched to 300 watts. On the right, the automation's notification in a specially created Telegram channel. To detect the start of the second stage, a binary template sensor is used. It contains two conditions that must be met simultaneously. The first stage switch is active, since if the station is working in normal mode, there is no need to start the second stage. The second, the battery charge level has reached 100%. The last line is a 1-minute delay before switching on, so the station can stop charging. I didn't set it any longer because during operation the charge level may drop by 1 to 2%. As soon as this binary sensor is activated, that is, 1 minute after the charge level reaches 100%, and provided the first stage switch is active, the second stage automation is triggered, where this sensor is the trigger. The actions begin with resetting the maximum charge level to 60%. This is part of the preparation for the third stage. Then the first stage switch is turned off, since it is already complete. And the second stage switch is activated. It will be needed for the sensor to transition to stage 3. The smart plug relay, through which the station is connected to the grid, is turned off. Now the load will discharge the station's battery. And, after a 5-second delay, a notification that stage 2 has started with the date and time of its start, the current battery charge level, and the set maximum charge level. The status of the smart plug, it should be off. This is what the transition to stage 2 looks like. On the left, we see that the second stage switch is now active. The charge level is 100%. The maximum charge level is 60%. In the center, on the diagram, we see that the grid power is 0. Everything consumed by the 88-watt load is coming from the battery. And on the right, the second stage notification, date and time of launch. 51 minutes have passed since the first stage began, the current battery charge level and the target charge level. The input socket status, off. Template sensor for the third stage. It will be triggered when the following conditions are met. The second stage switch is active and the electricity sensor is turned on, which happens after the EcoFlow output socket is turned off. It serves as the trigger for the automation that launches the third and final stage of the battery conditioning process. The actions are turning off the second stage switch and turning on the third stage switch. The input socket of the station is turned on. Now it needs to be charged. The delay time here is longer. I set it to 15 seconds. If necessary, you can make it longer, in case the station has completely shut down. In the notification, a message about the start of the third stage, date and time, current and maximum charge levels, statuses of the input socket and the station's output socket where the load is connected. And here I decided to implement additional monitoring, which I will talk about very soon. This is what it looks like. On the left, the third stage switch has been activated. The input voltage sensor shows that the input socket is on. Charging has begun up to 60% at a power of 300 watts. In the center, the diagram shows that the total power consumption from the grid is 390 watts, of which 300, according to the specified setting, goes to charge the battery and the rest to power the load connected to the station socket. And the notification in Telegram about the start of the third stage. The discharge took a little more than 4 hours. As a precaution, to be sure that power to the load will be restored, I added an extra layer of control. For this, I created 2 more template sensors. This one will be active if 2 conditions are met. The third stage switch is turned on, but the electricity sensor is still not receiving power. The second one will be triggered when power to the load is restored. This is because EcoFlow disables its inverter, and accordingly the socket, when discharged. And when power is applied, it does not turn it back on immediately. And to make sure that the station's socket is turned on, I added this control check. As the trigger here, I used a time pattern, 1 minute. That means that if the conditions are met, the automation will run every minute. And the condition here is the same sensor that turns on at the start of the third stage, but when there is still no power at the station's output. In this case, the automation attempts to forcefully turn on the socket. However, if the charge level is too low, or the station hasn't reconnected to the cloud yet, it may not work. Then another attempt will be made in 1 minute. But in this particular example, as we saw a bit earlier, this control wasn't needed, the socket turned on right away. When the socket finally turns on, the second control sensor will be triggered, which will launch the next automation. It doesn't do anything. It just resends the notification for the third stage. The only difference is in the first line, so as not to cause confusion. Thanks to this, you'll know that everything worked as expected. The final template sensor marks the completion of the battery conditioning. It is triggered when the third stage switch is active and the charge level reaches 60%. It serves as the trigger for the final automation in this package, the text version of which, as a reminder, can be found in the video description. The automation turns off the third stage switch, returning everything to its original state, and sends a notification about the completion of the battery conditioning process. The station can now be turned off and stored again, until it is needed or until the next conditioning cycle. Now the display looks the same as it did in the beginning. Only one more charge-discharge cycle has been completed. The battery charged up to 60%, which took 1 hour. All the energy supplied to the station is used to power its inverter and the connected load. Now it can be turned off and put away again until it's needed or for the next conditioning cycle. Considering that I have 4 EcoFlow stations with different capacities, this package, which I've scaled across all my devices, makes battery maintenance much easier. All I have to do is set up the station and start the process. The system does everything else automatically. After receiving the final notification, all that's left is to turn off and store the station. For high-capacity models, conditioning takes many hours, and keeping an eye on it is rather inconvenient. But this solution delegates the task to the smart home system. That's all for now. I hope the video was interesting and helpful to you. I'd appreciate your likes. They help with promotion on YouTube. If you don't want to miss new videos, subscribe to my channel. In the video description, I'll leave links to all the mentioned resources, as well as my Telegram channels, social networks, and groups for smart home discussions. Feel free to join. It'll be interesting. Thanks for your attention. See you soon. Peace to all.